Exercise 9.5, building a approach slab model. In this exercise, we will create an approach slab model by editing the template within the ITL and placing it in the file. So let's go ahead and create a new file and name it Road2 BR Bridge Approach Slab Model. And be sure to select the t.c2d DGN seed file and click Save. So once that file is created, make sure that the default view is active in the lower left corner, and let's go ahead and attach some files. We need to attach the alignments file, the bridge control file, the bridge models, which is the one we created in the last exercise, and the terrain file. And do this all by using the coincident world attachment method. Then hit Fit View and zoom in to our bridge. Go ahead and turn off the triangles in both the 2D and 3D models if it's not already. And then let's open up the Create Templates tool, which is located under Open Nose Modeling, Corridors, Create Template. Click File, Open, and select the Civil Templates T.I65 State Route 99 Bridge ITL saved from the previous exercise. We'll now create a new template. Under the T.Project Templates folder, right-click on the Templates subfolder and select New Templates. And we're going to name this template TS5 4-Lane Approach Slab. An empty template should now appear. Scroll up and select the TS5 6-Lane Approach Slab template. Under Linear Templates, T.Typical Sections, Bridge, and Approach Slab, and click on the template once so that the preview shows in the bottom left corner. Now right-click and drag the template into the Create Template window. Next, click View Extent to see the full template. Right-click within the Create Template window and select Change Template Origin. Then select the green Base MBCL point. Right-click in Space and select Delete Component. Then click and drag to draw through the components that need to be deleted. In this exercise, we need to delete the components between the EOP and LNC on both sides of the template. Next, open the point properties for the EOP-L point and update some of the constraints. First, we need to change the parent here to be this LNBL point. You can select these crosshairs and then just select the point, a little bit easier. And we need to make that constraint 1 value 2%. Then for the parent for the constraint 2, it'd be that same LNBL point. And the value needs to be -12. And then select Apply and Close. And then we can merge those points. So right-click on that EOP-L point and select Merge Points. And we want to delete the LNCL point. Then we need to update the constraints on the EOP-1L. So open the point properties, and then we're going to change the constraint 1 type to slope. The parent 1 to be that LNB1L. And the value here needs to be 2%. And then apply and close. And then we can merge those points as well. And be sure to delete the LNC1L point. We can also merge the points here at the bottom. So right-click, merge points, and delete the LNC4L bottom point. So now we can repeat those last few steps on the right side of the template. We're going to update the EOP-R points. So open its point properties. For the constraint 1, parent 1 needs to be the LNBR point. Or the value of this slope needs to be -2. And then parent 1 for constraint 2 needs to be that same LNBR point. And the value here needs to be 12. And then apply and close. And then merge those points together, being sure to delete the LNCR point. Then now we can work on this EOP1R point. For this, we need to change the constraint 1 type to slope, the parent to be that LNB1R point, and the value here be -2, and apply and close. Then we can merge these last couple points together. So merge and delete the LNC1R, and then merge the bottom points here and delete the LNC4R bot. So now our template should be looking like this and is now ready to be placed. So go ahead and select File and Save. We save this template. And then we can close this Create Template window. Now we can open the New Corridors tool under OpenRoads Modeling, Corridors Create, and select the I-65 middle center line. Then right click to use the active profile, and then left click to accept the name. Then select the template we just created, TS5 4-lane approach slab. Left click to lock that in, and then the start and stop stations here. You'll have two different template drops here. So the one at the beginning of the bridge, and then another at the end of the bridge. So the first one is going to be from station 421 plus 25.89 to 421 plus 50.89. Then at the end of the bridge, the last approach slab is going to be from station 424 plus 24.89 to 424 plus 49.89. Now attach the I-65 corridor DGN reference file using coincident world attachment method. And then we can notice how the bridge and approach slab do not line up with the roadway. And we go and open up that 3D view. So now we can go ahead and open up the bridge model DGN file. I'm going to go ahead and open up the 3D view. And go ahead and open up that Create Template tool again. And open the bridge template. So go ahead and open up the LNAL point properties. Now let's change the horizontal constraint to -30.23. Now let's change the slope constraint to 0%. And then hit Apply and Close. Let's change the constraint for the LNBL point. So we'll go ahead and open up that one's point properties. LNBL. This time we're going to change the horizontal constraints to -42.23. And make sure that the slope constraint here is set to 2%. And Apply and Close. Now we need to repeat those last two steps on the right side of the bridge. So LNAR point. Change the horizontal constraint to a +30.23 and the slope to 0. It's going to look weird, but let's open up the point properties for LNBR and change the value for constraint 1 to be +42.23. Let's make sure that the slope for the second constraint is set to -2%. And then Apply and Close. So once we have that completed, let's go ahead and save our template. So File, Save, and then we can close out this Create Template window. Then we can open up the Synchronize Template tool under OpenRoads Modeling, Corridors, Miscellaneous. And then select the bridge corridor. You can see how it widened, so now it should line up with the rest of the corridors. Then let's open up the Road2BR Bridge Approach Slab Model DGN file. So here we can see that the bridge is lining up, but the approach slabs are not. So now we need to edit them to match the constraints of the bridge. So within this new file, let's go ahead and open the Create Templates tool again. Let's open up the approach slab template and open up the LNAL point properties. And then similar to the bridge, we're going to make this horizontal constraint be negative 30.23 and the slope to be 0. And apply and close. And it's not going to look correct until we finish changing the other points. So let's open up the L and BL point properties. And set that horizontal constraint to negative 42.23. And we can leave that slope constraint to be 2%. And apply and close. Now we have the left side of our template looking good. So now we can repeat those last couple steps for the right side of the approach slab. So again, open up the LNAR point. And let's set the constraint 1 value to positive 30.23. And then the slope value to 0%. And apply and close. And then open up the point properties for L and BR. And again, horizontal constraint to a positive 42.23. And leave the slope constraint to negative 2% and apply and close. So let's go ahead and save the template and then close this Create Template window. Then once again, open up the Synchronize Template tool and then select the Approach Slab corridor. But note here that the bridge alignment does not line up exactly, as the inside lane will need to be point control to follow the PGL line like the main line does. But for this exercise, we're not going to be setting up the point control. Now we're going to set up a parametric constraint at the southwest corner of the bridge, starting at the beginning of the bridge and ending 7 feet from the beginning of the bridge approach slab. And the constraint will run for a total of 18 feet. So we're going to be working right here. Begin left of the bridge on the approach slab. Let's open up the Create Parametric tool under Open Doors Modeling, Corridors, Edit, and Edits. And select the Bridge Approach Model Corridor. And we're going to set the start station to 421 plus 32.89. The stop station to 421 plus 50.89. Set the constraint label to left barrier control. And then both the start and stop values as 1. And then we can left click through the prompts. And now we have the bridge barrier on the approach slab. So let's go ahead and repeat that process for the additional 3 corners of the bridge, but using the right barrier control constraints for the right side of the template. And at the other end of the bridge, the start and stop locations will be 424 plus 24.89, and then the end station will be 424 plus 42.89. So once you have all four of the right and left barriers placed, we can now place the bridge ends at the end of the concrete barrier. Now we need to place the right start bridge end first, which is the southeast corner, which is this corner, and this corner. So let's open the point tool, which is under Open Nodes Modeling, Geometry, Horizontal, and Point. So within this point dialog box, we're going to set up a few of the settings here. So the elevation mode needs to be Plan Element. Then on the screen it says Locate Elevation Plan Element. So we're going to select the I-65 corridor PSHR in the plan view, which is this purple line. Then the elevation offset is 0. The rotation mode is relative to alignment. Then we can set up the feature definition as Bridge End SS Right Start, which is located under Point, Roadside Barrier, and the bridge ends. Also set the rotation here to be North 0 East. Then we can left click through some prompts here. Then when it comes to locate reference element rotation, again select that PSHR line in the plan view. And then when it asks to enter data point, we can use the intersection snap and snap to the purple line here. So we're going to snap to the intersection of the PSHR and the end of the concrete barrier. And then left click again to select the rotation. And now we have our bridge in place for one bridge. And if you want to do the rest of the other three corners, you can just repeat these last few steps. Make sure to use the corresponding feature definition for each orientation. Note that the start and end are flipping for the left side, as the start and end is based on travel direction, such as the southwest corner will use the left end feature definition. So note that the only remaining step would be to change the bridge slopes from 4% to 2%. This would be done by creating a parametric constraint on the PSH lines in the main I-65 corridor model. The parametric constraint would be 90 feet from the start of the bridge to match the super elevation runout of the roadway. And note that for this parametric constraint to work on the PSH values, the PSH slope constraint rollover value will need to be turned off, meaning a separate template drop will be needed. Alternatively, a point control could be placed to control the shoulder vertically. And this ends exercise 9.5, building a approach slab model.